Welcome back to the course Site 101X on Technology Evaluation. I am Dan Fry, and I'm going to be reviewing the results of our solar lantern study, the product evaluation study on solar lanterns, with an emphasis on just one of our S's, which is suitability. This slide shows the overall process that we went through to make the product evaluation report, beginning with product family selection, going on through product testing and data analysis, and finally developing rating charts and evaluation reports, and also in a university environment, academic papers and theses by the students. Now, into the product family, we have 13 different lighting devices that we incorporated in the study. Some of them have a configuration that you would recognize as a lantern, like this one. But there are many different kinds of footprints. Here is one that has the shape of a smartphone. This one looks more like a desk lamp with a gooseneck to adjust the position of the light. Also, an important difference is some of these devices have separate photovoltaic panels. Others have the photovoltaic panels integrated into the solar lantern itself. So really a lot of variety across the product family. And let's begin to talk about how we did our work. A significant amount of our work was done in the field. We conducted interviews, for example, both before and after use by individuals and families in Uganda. We also did a pretty extensive study with sensors. We took 37 different lanterns and equipped them with data logging equipment and sensors and batteries. And our sensors gave us the ability to determine whether the lanterns were on or off, whether they were charging or discharging, and also whether they were being moved at any particular time because they included accelerometers. And this revealed a very important thing to us. There was a discrepancy between reported duration of use on average each day, according to surveys, and the duration that was revealed to us through recording by the sensors. And that discrepancy was almost a factor of 2. So we're happy to have more information thanks to the sensors. We also did extensive laboratory testing, including assessment of solar charge and discharge. That was conducted on a rooftop at MIT using natural solar light. We also went inside and did laboratory tests of lighting performance. We also did assessments of durability, including simulated rain tests as described in a previous lecture. Now, the solar charging studies always indicated to us a consistent pattern. We have here on a red line a indication of solar irradiation in watts per meter squared out on the roof. And then we could see tracking very clearly along with that is the current that is being supplied to the batteries to charge them up until such a time as it dropped quite precipitously, indicating to us that the charge was complete. And that was consistent across all the different solar lanterns, that kind of pattern, making determination of charge time quite straightforward. On the other hand, discharge performance varied in quite 2 distinct different patterns. One in which the discharge current was high until a time that it dropped down to a fraction of its previous value, as commanded by the electronics that were seeking to extend the battery's useful life, or by comparison, a different pattern in which the battery voltage trailed off and the discharge current followed it proportionally, making the exact threshold at which we would declare it to be out of charge a matter of a judgment call. Now, we did durability testing in 2 phases. We submerged the lanterns in water, and if they passed that test, could continue to light effectively even after being submerged in water, they were given an outstanding rating. On the other hand, if they did not pass that test, they underwent additional testing in simulated rain in a most vulnerable position and in an as charging position. Now we see the overall comparative rating chart for solar lanterns, and one of the things that jumps out for me is that the three most highly rated models in the study all received outstanding scores in three different metrics that were related to the quality of illumination. There was brightness, task lighting, and ambient lighting. Those three top models did not necessarily all do outstanding in luminous range. They varied quite substantially in that, but across those three different parameters, they all did outstanding. Now, importantly, they did not get great ratings in water resistance, these top three ones. They got average or poor ratings in water resistance. And that seems to be significant because many of the products that were in the middle of our survey in terms of ranking got outstanding ratings in water resistance. And this is curious because our surveys indicated that water resistance was a very high priority for users in Uganda. So I suspect that the fact that we subdivided the lighting quality into so many different metrics may have skewed the overall ratings in a certain way. So reflecting on our method, one thing that we see is that a consumer report style of chart with a single ranking based on a single set of weightings may not serve a diverse population of decision makers. If a decision maker valued water resistance more highly, they really ought to dig into the chart, and the information is there. They could just decide, for example, only to look at lanterns with outstanding water resistance, and all the information is still there, but the rankings may not be what they want to follow in making their decision. Also, discovering all the available models in a local market proved to be difficult. We arrived in Uganda, our team members did, and they found that some lanterns that were not discovered in our desk studies were available in the market. So in the future, we would consider partnering with a local group, an NGO, or perhaps a market research firm to ensure that we have discovered all of the different models in our product family that are available in a local market. This study also highlighted for us the importance of timely reporting and updating of our evaluation reports, because even within a year of publishing this report, there were new solar lanterns available in the market. Finally, I would note that scoping studies are really a non-trivial exercise. In this case, we might have considered including flashlights with disposable batteries in the study, since after all, they do provide illumination off-grid. And also it might be important to make a comparison between solar lanterns and the main technology they replace, which is kerosene lanterns. And those differences are very important to the users. So many lessons learned on methodology. Here are some image credits, and let me take a moment to remind you that there is an exercise related to this lecture. So please do give that a solid effort, because that's an important way of learning.